Hello everyone, welcome back to the channel. This is the last video for three-phase circuits. In this video, I'm going to solve four different problems based on two-wattmeter method, which I had discussed in the previous video. If you haven't checked that video, you can check. The link for the same is available in the description box. I had derived the formulas for reading of two wattmeters. W1 can be calculated as VLIL cos 30 minus phi, and W2 can be calculated from VLIL cos 30 plus phi. From W1 and W2, we can calculate the power consumed in the circuit, which is equal to W1 plus W2. We can also calculate reactive power, which can be calculated by root 3 times W1 minus W2. We can also calculate the phi as tan inverse root 3 W1 minus W2 upon W1 plus W2, and hence we can calculate the power factor, which is equal to cos phi. So by using the two readings only, we can do different calculations associated with the power. Now let's take all the problems one by one. First problem states two wattmeters connected to measure the power input to a balanced three-phase circuit indicate 2500 watt and 500 watt respectively. Find the power factor of the circuit when both readings are positive. So first part, W1 is 2500 watt, W2 is 500 watt. We need to find out the power factor. For that, let's find out the power factor angle, which is tan inverse root 3 W1 minus W2 upon W1 plus W2. So phi is tan inverse root 3 2500 minus 500 upon 2500 plus 500. Phi is 49.107 degrees. So cos phi is cos 49.107. It's 0.655 and its lagging power factor, since W1 is more than W2. The second case says the later reading is obtained after reversing the connections of the current coil. Now when we reverse the connections of either the current coil or potential coil, then we need to take the reading of that wattmeter as negative. It means W1 is remaining 2500 watt while W2 is minus 500 watt. The formula for calculating phi is same, that is tan inverse root 3 W1, which is 2500, W2 minus 500 upon W1 plus W2. So this gives the value of phi as 68.95 degrees, and then cos phi is 0.359, and it's again lagging power factor. Now moving on to the next problem. Here the problem says three choke coils with a resistance of 10 ohm and reactance of 10 ohm are connected in star across a three-phase 50 Hz 400 volt supply. Calculate line current reading of 2 wattmeters connected to measure the power. If the coils are now connected in delta across the same supply, find line current and reading of the 2 watt meters. It means we need to solve the problem for two different types of connections, firstly for star, then for delta. Now, irrespective of the connection, the phase impedance will remain same. Phase resistance is 10 ohm, reactance is also 10 ohm. So phase impedance, which is equal to R plus jx, that will be 10 plus j10 ohm. We can change it into the polar form, which is 14.14 angle 45 degree. So ZP will remain same. Now coming to the first part, when supply is connected in star, sorry, the coils are connected in star. So line voltage is 400 volts. In star connection, line voltage is equals to root 3 times Vp, or Vp is equals to VL by root 3. Since we are interested in calculating the line current is same as phase current. So let's find out the phase current first, which is voltage upon phase impedance. So phase voltage is 400 by root 3 volts. 400 by root 3, impedance is 14.14 angle 45 degree. So this gives the value of 5p, 16.33 angle minus 45 degree ampere. So minus 45 means this current is lagging behind the voltage by angle 45. So phi is 45 degree. The magnitude of phase current is 16.33 amperes, which is same as line current. So line current is 16.33 amperes. Now in second part, we have to find out the readings of 2 watt meters. W1 is equals to VL IL cos 30 minus 5. VL is 400, IL is 16.33 cos 30 minus 45, which gives the value of W1 as 6310.35 watts. W2 VL IL cos 30 plus 5. VL is 400, IL 16.33 cos 30 plus 45, giving us the value of W2 as 1690.61 watt. In third part, the same coils are now connected in delta. In delta connection, line voltage and phase voltage both are same, so it will be 400 volts. Line current is root 3 times phase current. Again, we need to find out phase current, which is equal to phase voltage upon phase impedance. Phase voltage 400, phase impedance is 14.14 angle 45. So this gives a value of IP as 28.29 angle minus 45 degree. So again phi is 45 degree. Magnitude of IP is 28.29 amperes. IL, which is equal to root 3 times IP. So it's root 3 into 28.29. It's 48.99 amperes. So this is the value of line current when the coils are connected in delta. Then we need to calculate the wattmeter readings. W1 VL IL cos 30 minus 5. VL 400 IL 48.99 cos 30 minus 45. So this gives a value of W1 189288 watts, and it's better to write this as 18.93 kilowatt. Then we can calculate W2 VLIL cos 30 plus 5 VL 400 IL 48.99 cos 30 plus 45. So W2 is 5071.82 watt or 5.071 kilowatt. Now moving on to the next problem. A three-phase star-connected load draws a line current of 25 amperes. So line current is 25 amperes. The load kVA and kilowatt are 20 and 16. So apparent power is 20 kVA, active power is 16 kilowatt. It means load is consuming 16 kilowatt power respectively. Find the readings on each of two wattmeters used to measure the three-phase power. Now how to calculate W1 and W2? For W1, VL IL cos 30 minus 5. W2 is VL IL cos 30 plus 5. Only IL is known to us. Then we have apparent power and active power. Now from apparent power and active power we can calculate cos phi, since we know that P is equals to S into cos phi. So cos phi is P upon S 16 by 20, which is 0.8. So this gives a value of phi as 36.87 degrees. Now once we have the value of cos phi, then from power we can power cos phi, and IL we can calculate the value of VL as well. Since power in three phase is root 3 times VL IL cos phi. Power is 16, it's in kilowatts. So 16 into 10 raised to power 3 equal to root 3 times VL. IL is 25 to 0.8. So VL over here, when we calculate, it comes out to be 461.88 volts. Now W1, which is equal to VL 461.88 into IL 25 into cos 30 minus 36.87. W1 is 11464.099 watt, and it's better to write this one as 11.464 kilowatts. Similarly W2 is VLIL cos 30 plus 5. VL is 461.88 IL is 25 to cos 30 plus 5, that is 36.87. So this gives a value of W2 as 4.54 kilowatt. So all these problems, they are formula based, and the last problem in this is three similar coils are connected to a three-phase 50 Hz supply. The line current taken is 25 amperes. Line current is 25 amperes and two wattmeters connected to indicate input power. Connected to measure the power indicate 10.37 kilowatt and 5.185 kilowatt respectively. Calculate first part line and phase voltages, and then in second part we have to calculate the resistance and reactance of each coil. Now again we can calculate the line voltage from the formula of power in three phase, that is root 3 times VL IL cos phi. IL is known to us, cos phi can be calculated from the two readings W1 and W2. Cos phi will be equal to cos of tan inverse root 3 W1 minus W2 upon W1 plus W2. Cos of tan inverse root 3, W1 is 10.37, W2 5.185, 10.37 plus 5.185, which gives a value of cos phi as 0.866 lagging. Now this cos phi can be used to find out the value of line voltage, since power can also be calculated from the two readings, which is W1 plus W2. W1 10.37, W2 5.186, 185. The total power is 15.555 kilowatt. So let's calculate VL as P upon root 3 IL cos phi. This is what we get from here. 15.555 into 10 raised to power 3 upon root 3 IL is 25, cos phi is 0.866. VL in this case is 414.81 volts. Now, since the coils are connected in, it's not mentioned that how they are connected. So let's say star connected. Three similar coils are connected to a star connected three-phase supply. So Vp will be equal to VL by root 3, or in better way we can say three similar coils are connected in star to a three-phase supply. So in star connection, line voltage and phase voltage are related by VL is equal to root 3 times Vp, or Vp is equal to VL by root 3. 414.81 by root 3 gives the value of phase voltage as 239.5 volts. The next part we need to calculate the resistance and the reactance of the coil as well. To find out the reactance and the resistance, we need to calculate the impedance first. Impedance will be equal to phase voltage upon phase current. Now in case of star connection, IP and IL both are same. So ZP can be written as Vp upon IL. Now this one is for star connection only. We have already solved this type of problems in the previous videos. The link for that videos is also available in the description box. Vp is 239.5, IL is 25, which will give us the value of Zp as 9.58 ohms. We had already calculated the power factor. We know Rp is equals to Zp into cos phi. So 9.58 into 0.866 gives the value of resistance Rp as 8.296 ohms. Xp can be either calculated from Zp square minus Rp square under root, or Xp is equals to Zp sin phi. So if we use Zp sin phi, Zp is 9.58. So sine of cos inverse 0.866, which will give us the value of Xp, that is the reactance of the coil, as 4.79 ohm. I hope this video is helpful to you in solving the problems of three-phase power measurement using 2-watt meter method. Thanks for watching the video.